Okay, so we have our AGD 306 Doppler radar. We also have a radar detector. This detects K, Ka band. Now there is a issue with this, is it does switch from K to Ka band when it receives 24 gigahertz. I'm going to show another module doing exactly the same thing, which is bang on 24. Irrelevant from that, if this is yapping away, it's receiving 24 gigahertz from that module. So what we're going to do is just run this now so you familiarise yourself with the chatter this gives out. And I will apologise, it's a horrible thing. It's a Chinese, there's a little chip in there, and I've absolutely pulled this up so you can see that's on. When I fire this up, there will be a delay. You might notice the light flashing below it. When the light stops flashing, it'll go. And basically what that is when you first switch this on, there is a Wi-Fi chip inside that you can pair to, and then you can program it and set it and whatnot by using the serial number on the model. Anyway, that's outside of the scope of this. Yeah, so, okay. So what I'll first do, well, in fact, it's already fired up, isn't it? So, okay, I will fire up the AGD 306. As I say, it will take a little bit of time to warm up. There we go. See, it said K-band there, and these aren't the best. But that little horn antenna inside there is a super heterodyne, which I'm going to tap into and use it for other things. Right, so what I'll do is I will just power off the AGD unit. That's completely powered off. As you can see, there's no chatter. So what we're about to do is about to fire that back up, and we're going to show that what Mark Steele has said about this unit penetrating your body and messing with your insides and cooking you from the inside out. It's a weapon, it's all this, it's all that. I'm going to show you what will stop. Well, it's not even stopping, it's what will reflect that 24 gigahertz Doppler radar. At the end of the day, this presence detector needs to reflect. And we're about to see it reflect off a piece of bacon. It will fully stop that horn antenna from receiving that. Now, if you look at this distance, we're round about 400 millimeters or 40 centimeters away. This, in the wild, is, I'd say most of the time, at least 3-4 meters away from a human being, and because of its tilt angle, its down tilt angle towards the ground, if you think of the beam really, unless you're in a position on the crossing to the other side or vice versa, you most of the time you're going to be about 6 meters away from this. This is 400 millimeters or 40 centimeters away. That's damn close. That outputs 100 milliwatts of power. Yep. So if you use inverse square law, clearly, if it was 800, it would be, the distance squared. So it's, yeah, I mean, come on. Okay. Anyway, let's get on with it. So we're going to use a piece of bacon, around about a millimeter thick. And we're going to power on our Doppler radar system, or our presence detector, human presence detector, vehicle presence detector. Okay, we'll let that ramp up. There's a bit of a delay, it's like it goes through a test sequence, then it ramps right up. Yeah, K-band. It's got the K-band, 24 gigahertz K-band. And it jumps K. It doesn't matter. Right, introducing the bacon. Without bacon. With bacon. Because everything is better with bacon. Without bacon. With bacon. Without bacon. With bacon. Everything's better with bacon. I shouldn't have to just keep doing this, should I? We can clearly see. Yeah. And you can shut up. Thank you very much. Okay, powering that down. Okay, so, and don't worry, that bacon will be consumed. Oh, yeah, it will. So, around about 40 centimetres. You know, not quite, because obviously the near field is just a few millimetres off. But, you know, we're in the Fresnel zone. We're quite close to it, but this isn't losing that much power density at 40 centimetres. And as I say, when it's on a traffic light system, it's metres away from you at any one time. And yeah, so it's mental to have to do this. And why is it that whenever I debunk stuff like this, there's always a pig involved? There's always bacon, like the pig skin when I did the the magneteers. I used pig skin because it's a good analogue for human skin. I even shaved it with a razor blade. I'm not going there. Just honestly, the steps I go to. But again, this can be replicated by anyone who gets their hands on these units. This is cheapo. This is cheap. This is just a radar detector, just a police radar detector. It detects cameras. That's all that is. It's cheap. Bacon. Cheap. And edible. So, you know, I'm not going to waste that. The radar detector, I'm not going to waste that because the super heterodyne receiver in there I can tap into, and hence why my oscilloscope is on it, because there's an output there. And that output, when it basically goes through and it pulls down the signal or down converts the signal, it down converts it to around about 1 gigahertz. So I have this module here that I'm going to put onto it. And I did move another K-band module back and forth and like just slightly put stuff in to attenuate it. And on the oscilloscope, it was going up and down in voltage. So stands to rights then that that's outputting a signal that I can read on an SDR radio or a spectrum analyzer, which would be brilliant. But that's something I've got to do, get round to doing. Busy this weekend, but I just thought I'd just do this simple part of the experiment, just to show that, yeah, bacon, 1 millimeter thick bacon, but according to Mark Steele, this can penetrate your body. No. It's kind of like the Barry Trower debunking I did. You know, Barry Trower thought that radio waves could travel through water. No. Or even, you know, the geoengineering HARP NextRad conspiracy theory that I debunked, where, you know, they didn't understand the three states of water and how they are affected how they affect radio waves differently in the three states. Same again, it's just simple physics. We have a medium, which is our bacon. Our bacon has a dielectric content, or should I say a relative permittivity. It's reflective to 24 gigahertz. We know this, that's why they're used as bloody human presence detectors. Why would you use a human presence detector that's absorbed by the fucking human. I mean, it's known science. It's science. If you don't know, you could go and Stack Overflow in the science section and ask the bloody question, and you get an answer. The first answer would probably be like, are you for fucking real? The second answer would be like, look, you're an idiot, but here it is. You can ask these questions in the scientific community, or there's established science. You just have to understand a little bit of STEM. This isn't even complicated. What I've done here is not complicated. It can be replicated in somebody's bedroom. And that's what makes it so sad, is you've got these people like Mark Steele opening these things up and claiming there's all these kind of ceramic materials. Well, it's not. It's a low dielectric constant PCB material, because a normal FR4 PCB material has too high a dielectric constant for 24 gigahertz. That's why this module here that I have been using to test all this stuff, that's not ceramic. That is not ceramic. It's a low dielectric constant PCB material that the antennas are mounted on, because if it was the FR4 that the Arduino is made out of, it would seriously fuck with it. And this is the thing. They don't understand, and they claim to understand. I'm a weapons expert. I used to make stuff like that. Did you fuck? Because if you did, you'd stop talking bollocks. And it's so frustrating that I can, with a piece of bacon and a cheapo fucking radar detector, I can prove that that's bullshit. And it just boggles the mind. But anyway, we're going to tear it down. We're going to do some more stuff, hopefully during the course of this video, because obviously I'm away this weekend and it'll be next weekend before I finalise this video. But hopefully I can get that unit onto there. The programmer wrote for Debunking Barry Trower, and the Arduino, wherever that bloody is, because that's a very similar unit. I just have to change the logarithm for that frequency. I can use that, reuse it, which is great. That's, recycling and all that, and having a working set to work with. So all that I coded can just fall into that, just change the logarithm for that frequency. And luckily, Analog Devices on their website give us a sheet on the PDF. There's a page which shows which parts of the logarithm to change, which values to give it. Brilliant. It's great when you work with stuff like that. It's just so in. But if I can get that to work on here, which I should do, just basically solder the ground onto the antenna horn, and then we'll get our central coaxial element there, and just literally connect it straight on into the computer, show it on the graph that I wrote. Beautiful. But anyway, that's that. That cannot penetrate your body. And don't forget, that bacon, that's not got a bloodstream flowing around it. That's not got ever new molecules passing through that section. It's not alive, basically. It's got no blood flow. It's got a lesser water content. It's literally dead meat. It's not living human flesh, which is repairing and changing itself all the bloody time and being flushed with fresh blood every few seconds. This is damn close as well. We've categorically proved that Mark Steele is wrong. That cannot penetrate your body. That cannot do internal damage to you. It cannot cook your brain. It cannot communicate with the nanobots in the vaccine or whatever fucking bullshit they want to make up. That cannot do it. It's impossible. Look at the distance. This is designed. This has 150 fucking meter range. Oh, sorry, actually, 120 meter range on it to go down a road. 120 meter range, and it can't get through a piece of bacon 40 centimeters away. Mr. Steele, stop talking bollocks.